Hello, academic stars around the world. Welcome back to Caltex Academy. Today, we're looking at episode number 3 of this series of Earth geometry. And in this question, we're looking at the distance between 2 points along the latitude. In episode number 2, we look at distance between 2 points on the Earth's surface along the longitude. The link of that video is in the description of this video. So without further ado, if you're excited just like me, come closer and let's dive into the video. So the question says, calculate the distance between two towns A and B located on Earth's surface. At A, 50 degrees south, 35 degrees west, and B, 50 degrees south and 25 degrees east. So if you see this question critically, you realize that we have these 2 points located in the southern hemisphere of the Earth. But of course, these 2 points are also located in a different hemisphere, the eastern and the western, because we can see here, this point A is in the western hemisphere and point B is in the eastern hemisphere. Meanwhile, along the north and the south hemisphere, it is generally located down since they share the same points, coordinate here of the latitude 50 degrees south. So we are advised to take the radius of the Earth as r equals to 6,400 kilometers and the value of pi as 22/7. So now we have some model here which has been drawn for us ready. Let's locate these 2 points on the globe. And I can take some reference point here that divide this into 2 equals part of the eastern hemisphere and western hemisphere. So along this, we also have 0 degrees. Maybe let's get more space here for our diagram to be clear. So here we have the southern hemisphere with S and north along this. So we can locate the first point here, 50 degrees south, and 50 degrees south will be somewhere here. This is just estimation. Now it also runs on the other side there. So the center of this cycle is somewhere here. And this is the center of the Earth. We can give there O. Now, the next one is 35 degrees west. So 35 degrees west would be around here. Now we can also draw this. Maybe let's alternate the color for the longitude and we can estimate something like that. Yep, I think this one is fairer. Now the point A is lying at this part, and let's also locate this. They are already in the same latitude of 50 degrees in the southern hemisphere, and this is the longitude that is 35 degrees in the western hemisphere. Now let's go ahead and also locate the next one in the eastern hemisphere, and that is 25 along the eastern from this origin. So it should be quite closer to this point than there, because this 25 is less than 35. So the diagram is not smooth, but at least you get the point, and therefore we need to join these 2 points A and B to this center here. Now, to be consistent, we can also join using the same color. And between them, we have this angle here. So this angle, we can call it theta. And the distance required for us to calculate is from A up to B. This is our distance we're requested to calculate. And you can see also here that the distance from this point, maybe we can give this one as A. Since we use N here, maybe let's use something like P as the center. From P to A, that is a small radius. Why we're using small radius is because it's not from the center here. Otherwise, the radius keep on changing from the highest radius along this axis, then to the southern hemisphere, reducing it smaller until it vanishes to a point S. The same applies to the northern hemisphere. So let's get more space in order for us to be able to get the distance AB from this triangle A, B, and P. Yep, if this is our diagram we have just picked out from here, the center for this cycle is P, and we have our A this side. Now we have here, that is B. So we need to have this angle theta, and since these two lines of longitude are in opposite sides of the longitude or the Greenwich meridian, then there must be, this was 25 degrees along the east. So we have to add them together, meaning our theta as the angle difference is given by the sum of the two angles because they're in different hemispheres. So we have 25 plus 35, making 60 degrees. And that is the angle sustained at the center by these 2 points A and B. Now next we need to get this point here having an angle of 50. Since the angle is shared with both points, that is A and B, then we can call it another angle. Maybe you can say phi equivalent to 50 degrees. So this information is already enough. We can go on and quote our formula to start calculating the distance AB. So now since this one here is a small r, last time we already derived the formula for small r is equivalent to the center degrees, that is theta, over 360 degrees times twice pi. And remember, r, small r, is given by capital R cosine of this angle phi. You can use alpha, beta, or any letter of your choice. So we will replace here our small r from our diagram here by our r capital times cosine of phi. So let's make substitution to our formula, and we have theta as 60 degrees over 360 degrees times the value 2. Then pi was given to us as 22 over 7, and we multiply this by our radius of the earth, that is 6,400, and we multiply this by cosine of the angle 50, and that is the angle that came from this latitude in which the two towns lie. So let's get our calculator and enter everything there and then get the results. So we have 60 divided by 360, and we multiply this by 2. We also multiply this by 22 over 7, and we multiply this by 6,400 times cosine of 50. This gives us a result of 4,000. Let's get more space here. So we have here 4,309.737878. Now let us round our answer here to 3 significant figures, and we have the distance AB can be approximated to 4,310 kilometers. So that is the distance between those two towns. So if I've gotten some value from this video, go ahead and subscribe to the channel. Share this video with your friends. Remember, sharing is caring. So in our next video, we're going to look at also the shortest distance between the 2 points. So see you in that video. Peace out.